Phantom voltage exists literally in every outlet, every socket, every light bulb in your home. I've talked about this more than once before, but today I'm going to prove the nature of this voltage. And not just prove it, I'll show you on the instruments exactly where it comes from. Right now, I've made a special light bulb. Actually, it's the remains of an LED bulb with wires soldered to the base, to this contact, and to the thread. And now I'm going to plug it into a socket where I have 30 volts of phantom voltage. We'll measure it and show where it comes from. Let's go. I've screwed it in. And now I'll show you. Here they are, 30 volts of phantom voltage. Yes, this device can deal with phantoms. If we switch to the low input impedance socket mode when measuring voltage, it will show 0. But this voltage is often measured by those who don't have such an expensive device, and people get scared. Where do these 30 volts come from? And sometimes it's 90. Even in this socket of mine, sometimes in the evenings, it's 90 volts. And now I'll show you where it comes from. My theory was that this is capacitive voltage. We have wires laid inside the walls. And especially, just imagine those houses where the wires are simply laid out in tracks. The whole ceiling is covered and they run parallel to each other. And these wires, especially the ones that are live, induce a capacitive pickup in the disconnected ones. Why exactly is it capacitive? This always bothered me. I connected this socket, and today, instead of this voltmeter, which just measures and shows the phantom, I'll connect an oscilloscope. One channel will be connected to the phantom, and the second channel I'll simply connect to the outlet. And we'll compare the voltage phases from the outlet and from the phantom voltage. You might ask, what's this thing for? This is an isolation transformer. It's for galvanic isolation of the mains from the oscilloscope. Because on this oscilloscope, its common leads, these crocodile clips, are interconnected. And so, to avoid directly connecting the phantom and the outlet, we had to galvanically isolate them using an isolation transformer. This transformer is 220 to 220. It doesn't step up or step down the voltage, it simply isolates the mains. Let's turn on our transformer. It's humming. And the signal is going to channel 1. Let's take a look. The frequency is 50 Hz. Yes, that's the mains voltage. We can reduce it a little bit. Now we'll send it to channel 2. For this, we apply the voltage from the phantom to this probe. Let's take a closer look. And we can see that our signals are not in phase. There's a phase shift. This means the phantom has some reactive nature. But the shift isn't 90 degrees. It's different from 90 degrees because there's also active resistance in the circuit. The phantom is very small. And now the most important proof. If I go and apply voltage to this bulb, the sharp blue and yellow lines should be in phase, because it will be the mains voltage in both cases. And that's how I'll prove that the phantom has a reactive nature, that is, capacitive. And while studying this phenomenon of phantom voltage, I happened to come across a letter from the NEMA Association on the internet. That's the National Electrical Manufacturers Association of America. And in it, the nature, character, and causes of this voltage are clearly spelled out in black and white. And it completely confirms my assumptions. Take a look at the date on the letter. This was quite a long time ago, so the topic isn't new, it's just that it hasn't been brought up. And digging deep into the subject of electrical wiring and all its nuances, I came across a topic I hadn't heard of before. And I'm sure that many of my viewers haven't either. Right now, in our homes, including in my own walls with this phantom, there is regular copper wiring. But in many old houses, including my mother's house, there's the usual Soviet-era aluminum wiring. Now it turns out, and I didn't know this before, there are some new types of aluminum wires. They look exactly like the old ones, but they just have one extra letter in their name. Instead of AVVB, AVVB, AVBSHV, AVVB, the letter S is added, which means aluminum alloy. But my goal with this energy literacy project is to find them and subject them to rigorous laboratory testing. Heat them under load, connect them using different methods, oxidize them, bury them in the ground, in other words, put them through every possible ordeal to see just how good this aluminum alloy really is. Aluminum alloy. They say it's not quite copper yet, but it's no longer just aluminum. But I don't take anyone's word for it. I want to get my hands on it and test it myself. Here in Belarus, these kinds of wires aren't common. But in Russia, I know they're starting to appear, and I have a big request. Those of you who live in apartment buildings, new developments, if your building has these aluminum alloy wires installed, I would really appreciate it if you could write in the comments about how they're performing. Have you encountered any problems, like outlets overheating, having to replace outlets, or any other issues during use? Share in the comments everything you know or have seen about these wires. This is very important to me. I've also started looking into the global use of aluminum alloy, and it turns out that in China and India, on a large scale, they are also switching to aluminum. Even though America had a bad experience with regular aluminum in the 1970s and switched completely to copper, China and India, the two most populous countries in the world, are still considering aluminum as an alternative. And as the creator of Energolikbez, I can't ignore such trends in electrical products. I will be finding out the opinions of my Chinese and Indian colleagues, what is happening with this issue there and what will happen next. This topic will definitely be continued. I plan to release a series of short videos and maybe even a long one. If I gather enough information about this aluminum alloy, be sure to write in the comments if you live in apartments or houses with wiring made from aluminum alloy. That would really help me out, guys. Alright, let's go to the switch. I don't know how to show the camera here and there at the same time. Okay, the switch. There we go, I'm supplying power to this light bulb. Run, 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 run. Right now we can see that the phase alignment is perfect. This is the mains voltage and this is also the mains voltage. It's just that different scales are selected now so that both curves don't overlap each other. That's why I simply reduced the blue one so you could see both. The most important thing here is the comparison itself. When I disconnected the power supply, it was a pure phantom and there was a phase shift. Apat! Then I turned on the power supply and the phase shift between the mains and the bulb disappeared. It disappeared, you see? It disappeared, and that's important. So we looked at it in comparison. Not the absolute value of the shift, but in comparison. The phantom voltage was lagging behind the mains voltage, and it leveled out as soon as we applied real mains power to the socket. And that means there is a reactive element between them, between the phantom and the mains. And this reactive element is the capacitance of the mains. Most people ask whether you can use the current from this phantom. Look, 18.7 to 18.6 microamperes. Specifically, I have 30 volts, 18.6 millionths of an ampere. No guys, you can't use this current. And it's more harmful than useful. Remember, people often write in the comments asking why LED lamps glow dimly. So this little phantom can ignite faulty drivers, meaning it can charge capacitors and make LED lamps glow. And how do you deal with this? You install a special X-class capacitor in parallel with the lamp, 0.2 to 0.6 microfarads at 400 volts. The capacitor will shunt this current without drawing the current that the meter counts. By the way, any energy that comes into your house, including this phantom energy, it doesn't bypass the meter, it all goes through the meter. But this phantom is parasitic energy that just seeps through the capacitance into your sockets, lamps, to the LEDs, but doesn't do any useful work. On the contrary, it only gets in the way, making your LEDs glow at night. That's why I'll also include additional information in the description. Be sure to read it and share this video with everyone. Who else has these problems? Whose lamps are glowing faintly? And who doesn't know why there are 30, 40, 80, 90 or even 100 volts in their lamp socket? And what should you do about it? Why is the phantom voltage out of phase with the mains voltage? I have a feeling this will be a topic for engineering debates, which will continue in the Energolikbez Telegram channel. There we will analyze the vector diagram and the device connection diagram. This will be interesting. This is a safe phantom and rather harmful. If you have modern lighting, use electricity safely. Stay positive. This was a phantom researcher with you. Energy education. Malkov Alexander. See you.